rational numbers, no need for definitions today. In fact, there's really not a lot of definitions in this chapter, so it will not be a big part of this chapter. So equivalent rational numbers. When I say the word equivalent, what word do you think? Same or equal, right. So in a sense, I'm saying equal or same. Yep, that is fine. So we're going to be writing things. Again, we've covered concepts before like this. 3/10 is the same as 30/100, which is, of course, the same as 300,000ths, right? Those are equivalent numbers, rational numbers. If it was fractions, and we'll cover it in more depth, but 1/2 is the same as 2/4, which is the same thing as 3/6. Also, all equivalent to each other because they all equal the same thing. In the end here, they look a little different on the surface, but truth be told, they are the same. They are equivalent. They are equal. So number 3 says write each fraction or mixed number as an equivalent decimal. We are converting fractions to decimals, which you did in 4-1. The only difference this time is now we have a whole number component here. So for number 3, it says 2 7/10. The question is, what is that as a decimal? So 2 different components going on here. In 4-1, we just figured out the decimal because they were all proper fractions. They all had values less than 1. These are all mixed numbers. So when you're writing them as a decimal, and again, I would expect everybody already knows this part here, but before the decimal, I would have a 2. Then the fraction, what is 7/10 as a decimal? It's 0.7. 2 7/10 is the same as 2 plus 7/10. 2 7/10 is the same as 2 plus 7/10. So a mixed number, a decimal, in a sense, they are like a hidden addition problem, right? It's got a value bigger than 2, but it's also got a value less than 3. Of course, there's no shortage of numbers that could exist between those two numbers, right? Agreed? So try number 5. So you can approach this one of 2 ways here. You can certainly go 25 divided by 8, set it up, and solve. Or you can choose to rewrite it in mixed number form first. Do we all know how to convert improper fractions to mixed numbers? If I said write this as a mixed number, what would it be? 25/8. 3 1/8. How'd you get it?
I divided 8 and 25, and then the remaining number I put on top.
Yeah, basically, if you're converting any like improper fraction, and you'll have to do this next chapter quite a bit. This is not a big focus of our work at the moment, but if we're converting any mixed number to a fraction, right, you can set up a little division bar. Denominator is your divisor, numerator is your dividend, divide, remainder, your quotient, that's your whole number, your remainder, that's your numerator, your denominator or your divisor, that never changes. That never changes. And easy to check, to go back, to convert any mixed number to improper fraction. If you don't remember, take your denominator, multiply it by the whole number. 8 times 3 is 24. And then take that product, add on the numerator. 24 plus 1 is 25. Denominator never changes. Right back to where this whole thing started. So being able to go between those 2 forms.
Where'd you get that pencil?
I have no idea, to be honest with you.
I'll take it.
I didn't even know. Here you go, you can have it right now. There you go. I have another one right here. I don't know. Okay. So however you want to choose it though, you can do it this way, drop a decimal, continue, or if you did it this way, if you know your eighths, 125, 125, you should come up with 3 and 125 thousandths in the end here. So whole number part, fractional part, in a way, 2 different things to consider here. Number 9.
Happy number. Oh, what?
This one should be pretty easy. In
Oh,
fact,
yeah.
it's so easy, I'm going right for the stick. So decimal, sure, negative.
10,000.
Brooke,
Second one.
should not need to set up a division bar for this one because it's already in power of 10 form. So this one's as simple as just,
Okay.
how many zeros do I need?
3.
Like that.
Yeah.
Tenths, hundreds, thousands, 10,000s, 100,000s.
68 100,000.
Well, that's a 10,000.
68 10,000.
Well, you gave me, that's not the number. So how many zeros?
2. And then 68. Wait.
Tenths, hundreds, thousands, 10,000s. 68 10,000s. You gave me 68 100,000s. That would be 68 over 100,000. That's what you gave me. Okay, good with that. We could practice more and more of these, but what's the point? Next part, go in the other direction. So now you see your decimals.
Now you don't.
You need to, your
Fine.
boys, shh. And again, there's 2 people taking a quiz in here, so just go in the other direction now. They give you the decimal, you write the corresponding fraction. But the key is, well, I guess this is the only time they won't have you do it. I guess they won't have you simplify. So don't worry about simplifying. This will be pretty much the one and only time you don't have to worry about simplifying a fraction. Okay? But you do not have to simplify right now. So don't. You'll have lots of time to do it, I assure you. Thanks, Sam. So number 22,
That's even.
or 23 then.
I
think that'd be okay. 23. Really helps if you can just say the number in words in your mind. What number is that in words?
83.
83 what? 83 thousandths, or 83 over 1,000. Boom. Written as an equivalent fraction. You guys try, I'll pull a couple sticks. 25, again, writing a mixed number. 27,
Oh,
that should be good.
what was that?
And I guess 29. Boys, just, everybody should just be quiet. Won't take long. Say it, say the number in your head to yourself, and then it should be pretty easy, I think, to write the fraction. Because you just write what you just said to yourself. I guess pay attention to the negative things. That answer's going to be negative. That answer's going to be negative. Okay, 25. Jackson,
So, 4 and 100.
4.
4 and 1 over.
Right. Yeah, literally, if you can say it with words, then I don't know how you can't write it, because you don't need to simplify right now. 27, Dom. Negative.
Negative 12 and 31 over 1,000.
Right, over
Oh, that's so
1,000.
blurry.
Yeah, I was just thinking that too. Right, negative 12 and 31 thousandths. Negative 12, fraction part, 31 over 1,000. 29, Evangeline, negative.
Negative 4 and 58 over 100.
Right, 5,800. And of course, normally we'd simplify this, but for what we're accomplishing at the moment here, that is not the objective. So just leave it in unsimplified form. Good with this part? Yes?
Yep, yep.
Great. Last part, more of this graphing stuff here. I'm going to create a different scenario here. We're not going to go too deep with it. So let's all create a line, 0. I'm going to cut it into 2, 3, 4, 6. That's what I want. So there. There's 0, there's 1, there's -1, 1, 2, 3, 4, 5, boom. Hint, I made it in sixth. Hard word to say, sixth. Sixth. Well, whatever I did.
6, 7.
So let's see here. And then I want to graph 1/3, -5, 6, 0.25, thanks Faith, and -0.6 repeating. So graph those 4 points on the number line. Again, make sure yours is cut into 6, 0, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. Again, normally you'll have to fill that part in, but I need you to make sure you have the right number of lines. When you're doing your homework, the first thing you're going to want to do is figure out what these lines all mean. Is that eighths, sixths, tenths, twelfths? What are all these lines representing? So you'll want to count it all out. Start with here, 1. How many did it take you to get to here? That's your bottom number, your fraction. So whenever you're dealing with these number lines, the first thing you have to do you can write it with decimals, you can write it with fractions. How much you want to fill in on this is totally dependent on how comfortable you are seeing the missing information. You can write as much or as little as you want here. But 1/6, 2/6, which of course is the same thing as 1/3, 3/6, which is the same as 1/2, 4/6, that's also 2/3, 5/6. This would be 6/6, which is already 1. Same thing the other direction. The only one, this decimal here, and this decimal here, I'm not going to write all the decimal equivalents out, but I should know that 2/6 is 0.3 repeating. I should know that 1/6 is 0.5, and I should know that 4/6 or 2/3 is 0.6 repeating. Those I should know. I should know what 1/3, 1/2, and 2/3 as decimals are as a 7th grader already. Right? 1/3, 0.3 repeating. 2/3, 0.6 repeating. Check it on your calculator. 1 divided by 3, 2 divided by 3. 3/3, of course, is not 0.9 repeating. It's 1. It's a whole. It's 1. There is no 0.9 repeating. So these at least you should know. The fraction shouldn't be hard. You could rewrite this as 2/6. Why does that matter? Because our whole thing was written in sixth. So maybe you want to rewrite your fraction in sixth form. But where's 2/6? Should be right there. -5/6, 1/6, 2/6, 3/6, 4/6, 5/6. That one's right there. There's -5/6 right here. -0.6 repeating is the same thing as -2/3, which is the same thing as -4/6. 1, 6, 2, 6, 3, 6. So that one would be right there.
Oh, negative.
Right?
Yeah.
This one, 0.25. This one, of course, would be 1/4. But where's it going to go? How do I plot it here? Well, I know where 0.3 repeating is, 0.333. 0.116 is 0.16 with the 6 repeating, by the way, just what it is. So 0.25, I may not know all this. I should at least be able to figure out 1/4 or 0.25 is bigger than 1/6, right? I mean, just compare them. 1/4 is bigger than 1/6, right? But it's not as big as 1/3. 0.25 is bigger than 0.16, but less. So how do I plot it there? I just go maybe somewhere in the middle, like that, right?
Yeah.
That's about where it would be. I wouldn't necessarily plot it on either of the lines because it's not 1/6, it's not 2/6, it's not 1/3, it's not any of that. But it's between these two values. Now, does it need to be like perfectly like, oh, it's actually a little closer that way? Well, no, we don't have to get that deep into it. But if I was looking for you to plot this point here, I would be looking for a point that's in between these two lines. Right? Does that make sense? So, and that's not an abnormal thing with number lines as you get bigger. There will be sometimes points that will not fit perfectly clean on the lines. So what do you do with it? Well, again, you usually just get it in the middle there. That's what you do. That's how you represent it. Does that make sense? Do you guys feel all right with your graphing skills and number lines? Do you want me to do another one? I can do a smaller one real fast.
I don't know.
Anybody?
Sure.
Okay, let's do one more. So this time you can figure out what it's cut into. Make it a little smaller. And then I will have you graph 1/2.
How many are there?
0.4, negative 3/5, negative 0.7. So this time I'll let you try and interpret the graph yourself. What did I make the graph into? What's the fractional component being represented? Once you know that, then you can start plotting points. But you can't put any points down if you have no idea what all these lines are representing. Otherwise, where are any of these points going to go? Tomorrow, you guys just have a lesson on comparing greater than, less than, or equal to with decimal. Yeah, actually. So electronic me, I'll probably take care of that one. And I'll work with you guys tomorrow. You'll skip 4-4. Estimating lesson, don't care. And then 4-5, adding and subtracting with decimals. So that's kind of where the chapter really begins, 4-5 for you. Oh, sorry, Sig. Yep. Very light lesson tomorrow. Very light lesson tomorrow.
Yeah, but this is
And again, I'll give you guys electronic me tomorrow and I'll work with you guys. You guys are starting now the new part of your algebra work, so it's going to get a little more,
You can put that song on the
I don't want to say harder, but longer. How's that? On the flip side, if you looked ahead, did you see some of your upcoming homework lessons? Dude, there's like 3 problems to do. Like it's just 1, 2, 3, 4. Then it's just this huge gap between them in the homework. So you're gonna have a number of homeworks that only have like 3 problems, 3 or 4 problems.
That's amazing. I love that.
They take longer, more
Yeah, but
steps.
still, that's like half of the time it takes to do one of ours now.
It's not a ton harder, I don't think, you guys, but it'll be new. So, and then when we like 5 days, that's kind of our limit of where we're going with algebra. We'll hit a point. So, okay, 1/2. So 1/2. If I divide it out here, I would end up with 0.5. You can totally up to you how you want to write it. 1/5, 2/5, 3/5, 4/5. Maybe you did that. Maybe you did decimals. 0.2, 0.4, 0.6, 0.8. Maybe you did both. Same thing with all the negatives. I don't need to write it all in, but you can continue the pattern there. So if that's a strategy that you need to use to get these in the right spots, then do it. Don't feel you're being rushed or anything by me. Do what you need to do, or as much or as little as you need to do to get these. But 1/2 is 5/10. 1/2, That's 4/10. That's 6/10. It is literally smack dab in the middle between these 2 points. Right here is where 1/2 would be. Right, it is between 4/10 and 6/10. Think about it this way. 2/5 is 4/10. 3/5 is 6/10, right? 2/5, 4/10, 3/5, 6/10. 1/2 is 5/10, right? Because there's your 2/5, there's your 3/5, but 1/2, right? So if I was ordering them, we could see greatest to least, but a lot of ways you can think about this here. 4/10, 0.4, it's the same as 2/5 right there. Negative 3/5 is the name is negative 6/10. 1/5, 2/5, 3/5, negative onto the left. And then negative 7/10 is pretty much very similar to what the 1/2 was, except it's right in between negative 6/10 and negative 8/10. 3/5 is 6/10. 8/10 or 4/5 is 8/10. 7/10 is literally between 3/5 and 4/5. So if I put a dot, it would again be in the middle between those two lines right there, representing a value that's greater than negative 4/5, but also less than negative 3/5. Okay? So homework, if you're doing the thing, page 85, 86, 2 through 42, even. That's what we got. Okay. Questions? Good to go?
Wait.
6th grade, I'll check your homework first tomorrow.